Right, let's move on to question 4 in the sample paper that the examinations.ie has put up. So the coordinate diagram below shows the triangle ABC. The point A has coordinates 4, 2. The point A, so over 4 on your x-axis, it's always x comma y when we're looking at points. So over 4 on the x-axis, that's the 4, and up 2, and that gives you the location of A. Write down the coordinates of the points B and the point C. So let's look at the point B first. So over 8 on the x-axis, this is our x-axis, over 8, we don't go up or down any, so it's 8, 0. Let's have a look at C. Over 10 on the x-axis and up 4 on the y-axis. So 10, 4. So you remember that as x comes before y in the alphabet. So when you're writing down points, x coordinate comes down first and then your y. Okay, and it's like the location on a map of where the point is. Over 10 steps, up 4. Okay, so that's B and C. B then, part B. The table below shows the equation of the lines AC and AB where M and K are rational numbers. Work out the value of M and the value of K. Okay, so not the easiest of questions, this one. It looks quite intimidating. So let's have a look at it. The table below shows the equations. Okay, so where am I? In the log tables, whenever I see any coordinate geometry, and you know that because it's talking about points, we go to the coordinate geometry page, wherever that is. Here, I must have went by it. Okay, so page 18 of your log tables gives you all the formulas. Okay, so up here it tells you how to plot a point, x1, y1, okay? And you also use that for labeling points. If I'm asked a question about the slope, I use that formula. If I'm asked for the length of a line, it's this formula. Midpoint is this formula. Equation of a line. To find the equation of a line, I use the top one, y minus y1 equals m times x minus x1. If I'm given the equation of a line and I have to do something with it, I'll use the bottom one, y is equal to mx plus c. Okay, this one isn't on your course. This one not really, although it's a handy formula. Okay, so to find the equation of a line then, I'm using this, okay? So I'm going to copy this across so we can have a look at them. Okay. So that's what's in the log tables. So like I said, to find the equation of the line, you're using the top one. Y minus y1 equals m times x minus x1. And this is why it's so important that you're used to using your log tables, because you get handed out your log tables in your junior cert exam. And if you're doing mocks, make sure you check with your school as to whether they're handing you out log tables or whether you're supposed to bring in your own one. But make sure you have a copy of your log tables. They're every bit as important as your calculator in your exam. Okay, so y minus y1. So see the m here in it? That m is slope. If you go back here, m is the letter that they use for slope. So to find the equation of a line, in many cases, you end up finding the slope first. Okay, so the table below shows the equations of the lines AC and AB, and you can see I have bits missing, okay? So the easiest thing to do is to just find the equation of that line. Okay, so I would start it as y minus y1 equals m times x minus x1. Okay, if I have the points A and C, then, or if it's the equation of the line AC, I need to use these points. So A is 4, 2. I got that from here. And then C is 10, 4. And I label them just like it told me here in the log tables, x1, y1, x2, y2. So let's label them x1, y1, x2, y2. Okay, so that's the first job done. We have our equation and we have our points labeled. Okay, so to use that formula, I need to first find the slope. Okay, so let's write down our equation for our slope. It's y2 minus y1 over x2 minus x1. And it's very important you write down your formulas so that at least the examiner can give you marks for knowing which formulas to use. Okay, so let's work out that slope. y2, we labelled it as 4. So you're just subbing in the values that you just labelled, minus y1, which is 2. And then on the bottom, I have x2, which is 10, minus x1, which is 4. You can hit the fraction button and put that into the calculator if you wish. I'll do that here with you now. So hit the fraction button, and on the top I have 4 minus 2, and on the bottom I have 10 minus 4. So I got a third for that. So that's my slope. Okay, what do I do with it then, right? Well, that's the first piece that I needed for my formula, y minus y1. So now I'm going to sub that slope, m is equal to a third, in here for m. Okay, x and y stays x and y. It's an equation you're generating, and as you know, an equation always has x's and y's in it. And then I sub in for my x1, y1 there. Okay, so let's do that. So y minus y1 is equal to m times x minus x1. Okay, so y minus, let's go back up for my y1, it's 2, equals my slope that I just found is a third, times x minus x1, which is 4. Okay, y minus 2, just like any other algebra, I need to multiply in this third. A third by x is a third x. A third by minus 4 is minus 4 over 3. And of course, you can use your calculator for that. Don't worry about it. You can put into your calculator third, multiply by minus 4. Okay, I need to tidy it up then. So I'm going to plus 2 to both sides. Okay, because I want to add these two numbers together, look. So they cancel. And then I have y is equal to a third x minus 4 over 3 plus 2. So into your calculator then. So therefore y is equal to a third x. And into my calculator I'm going minus 4 over 3 plus 2. And I get plus 2 over 3. So that is the equation of that line. Okay, you'll see in some other ones that I do that sometimes I multiply across by 3 or bring that 3 over there. Okay, that is another way you can multiply in the third. I didn't do that in this case because I saw the fraction up here. So I figured they didn't multiply across by 3 to get rid of the fractions. They couldn't have done that when there was a fraction in the answer. So I needed my one to look like their one. So that's why here I didn't multiply across by 3. Okay, and if you look at some of our earlier videos on the line, you'll see, or on coordinate geometry, you'll see that we may have done that. Okay, so then what is m? The question here says, what is m? Well, m is the number that sits in front of x. So I know I'm right now. How do I know I'm right? Well, I have y on the left. Look, that matches. The 2/3 matches. So my m then is the number in front of x. So m is a third. Okay. And that's how you do them. So it's the same we're going to do now with AB. It's the same thing again. Y, we're going to take down our points so that the line we're dealing with this time is A and B. So let's take down A is again 4, 2. B this time though is the point 8, 0. Let's label them like we did on the last one, x1, y1, x2, y2. And let's find our slope. So it's y2 minus y1 over x2 minus x1. So it's equal to y2 minus y1 over x2 minus x1. So hit the fraction button. And I've got minus a half for that. So my slope this time is minus a half. Okay, I'm going to just insert a new page now so we have a bit of room. Okay, so my slope is minus a half. Someone to copy. Okay, I've just copied that over from the other page. Okay, so my slope is a half, is minus a half. So I'm going to sub it into now the equation of the line. Y minus y1 is equal to m times x minus x1. Okay, so you can see our labeled points. So we're going to use x1, y1, and we're going to use this slope that we found just to be a half. Okay, so y minus my y1 is 2. My slope is minus a half times x minus x1, which is 4. Okay, and x and y stays x and y. So just like before, I'm going to multiply in the brackets. That's what we did here. And again, I'm not going to multiply across by 2 because I see the fraction here in front of the x, okay? So y minus 2 equals minus a half by x is minus a half x. Now onto your calculator, minus a half, multiply by minus 4, and you should be getting 2. Okay, so I need to merge the two numbers here and here, okay, to tidy up. So I'm going to plus 2 to both sides. And I end up with y being equal to minus a half x plus 2 and 2 is 4. So that's the equation of that line. Does it feel right? Well, I've got y and y that matches. I have minus a half x and minus a half x that matches. So we're looking good. So k must be 4. Okay. So that was part B. So not the most straightforward, really does examine whether you can find the equation of a line. Okay, so the next part, show that the area of the triangle ABC is 10 square units. Okay, so area of a triangle. So it can be half the base by the perpendicular height. Okay, that works. Okay, to use this formula though, you have to be careful of a couple of things. You have to be careful, well, you have to be careful of one thing in particular, that you have a perpendicular height. So there's a difference between a slant height and a perpendicular height. So if I draw just a rough triangle, okay, my usual brilliant drawing, okay, and I draw a line down the center. So this here is what we call slant height, okay, and obviously it's going from bottom to top, but it's at a slant. And this one here is the perpendicular height. Okay, so it's straight up from the bottom, and there's always a right angle between the bottom and the perpendicular line. Okay, and that's how you know that that's the perpendicular height, and that also is a slant height. Okay, so you have to be careful when you use the area of a triangle formula that you're taking a perpendicular height. So when you're looking at a triangle like this, and if you get a question like this, there needs to be a right angle in it. So there needs to be a 90 degrees like there is here. So I'm thinking this one here is 90 degrees or is perpendicular. Now the only thing is you would need to be able to show that it's perpendicular. Okay, and the way you show two lines are perpendicular is using their slopes. Okay, so for perpendicular lines, okay, turn one slope upside down and change the sign. Okay, that sound familiar to everyone? to get the other slope. Or there's a formula, slope 1 multiplied by slope 2 will give you -1. That is all for perpendicular lines. Okay, and that is one of the most essential things you need to know on your junior cert higher level course. Perpendicular lines turn the slopes upside down and change the sign, or slope 1 by slope 2 will give you -1. For parallel lines, then slopes are equal. Okay, so I'd like to show that this line is perpendicular to this line. Okay, and then I can use half the base by the perpendicular height. Okay, now this is one way of doing it. This formula here is another way of doing it. Okay, but I'm going to do it this way with you because that's the formula that's used most often in the junior cert course. Okay, so I need the slope of AB to prove that, and I need the slope of BC. So I'm going back to the previous question, not you, here, to see did I get one of these slopes. So AB, and BC. So I'm looking at the ones that I got the equations of. I got AB here. So remember we did get slope. So it's -1/2. Okay, so let's write down slope of AB is equal to -1/2. Okay, so therefore, if these are perpendicular lines, then the slope of AB or slope of BC is going to be, we'll turn a half upside down, and can you see you get 2/1? Okay, I literally just flicked it upside down. So the 2 is on the top, the 1 is on the bottom, and change the sign. So instead of being a minus, it's a plus, okay? Which is the same, 2/1 is 2. So that's a slope of 2. So if these are perpendicular lines, I should get a slope of 2 for BC, okay? And therefore, I can then use this formula, okay? So let's get the slope of BC and see do we get 2. Okay, so the first thing we need to do is write down our points, B again. So if you remember, that was 8, 0, and C was 10, 4. Let's label them x1, y1, x2, y2. And let's find our slope. So M is equal to y2 minus y1 over x2 minus x1. So y2 is 4. So I'm going to have 4 minus 0 on the top. And on the bottom, I'm going to have 10 minus 8. So 4 minus 0 is 4, 10 minus 8 is 2, so 4/2 is 2. Okay, therefore, so M1 by M2 is equal to -1 for perpendicular lines. Okay, so -1/2 by 2 is equal to -1. Okay, just in case you've learned this formula, depending on your school. Okay, so they are perpendicular lines. Okay, so that's good. I can now use half the base by the perpendicular height. Okay, I've still got a good bit to go because I have to get the length of this line, AB and BC, because that's my base, that's my perpendicular height. It is also perfectly okay if you swing your screen around and he becomes your base and he becomes your perpendicular height. That's perfectly fine too. Okay, so how do I get the length of a line? Well, I use this one here. The square root of x2 minus x1 to be squared plus y2 minus y1 to be squared. Okay, so the length of AB uses this formula. Okay, so x2 minus x1 to be squared plus y2 minus y1 ought to be squared. Okay, so let me write down the points. A again is 4, 2. B is the points 8, 0. Let's label them x1, y1, x2, y2. Let's get the length of that line. So it's equal to I meant to put in the values. x2, which is 8 minus 4, ought to be squared, plus y2 minus y1 ought to be squared. Okay, so I'm literally just putting these 4 numbers in the right place. Then you take your calculator you hit the square root sign, you hit bracket, and you put this in exactly as you've written, plus bracket 0 minus 2 all to be squared. And I get 2 root 5 for that. So you can leave it as a surd, that's what that's called when there's a square root sign in it, or of course you can S to D it to change it to a decimal if you want, okay? It's up to you. Right, let's get the length then of BC. So I'm going to use these 2 points here and put them into the same formula. So it's the square root of x2 minus x1, so 10 minus 8, plus y2, 4 minus 0, ought to be squared. And again, into the calculator again. So square root, bracket, 10 minus 8, close your bracket, ought to be squared, plus bracket, 4 minus 0, ought to be squared. So I got 2 root 5 for that. Okay. Okay, so then if I'm going to get the area of the triangle, area is equal to half the base by the perpendicular height. So it's half of 2 root 5 by 2 root 5. And again, I just put that into the calculator exactly as it's written there. So a half bracket 2 root 5, come out from under the square root sign and close your bracket. Open up a new bracket, 2 root 5 again, go over so you're out from under the square root sign, close your bracket again. So it's 10 units squared. Okay, so a fair old bit of work for that. If you run out of space as you're writing down your answers, there's generally spare pages at the back of the answer book. So just write a note down here for the examiner and go to a new page, just like I have to go to a new page when I need more space, okay? And just tell them it's on page whatever of the answer book, or continued on page 20 or whatever it's going to be. Okay, and then if you run out of pages completely, if you put up your hand to the invigilator and just ask them for more paper, you can get more paper. Okay, but just tell the examiner, the corrector, where to find the rest of it. So 10 units squared. Okay, the question then said part D, the triangle A-B-C- is the image of ABC under axial symmetry in the x-axis. Draw the triangle A-B-C- on the coordinate diagram. So there's a few different symmetries on your course. Axial symmetry is one of them. Excuse me just for a sec. Axial symmetry in the x-axis is one. Axial symmetry in the y-axis is another. Axial symmetry, or central symmetry is another one, or symmetry through a point is another one. Translation is another one, so on and so forth, okay? So let me know if you need me to do any questions on these, just to go through them all. So how are we going to do axial symmetry through the x-axis? Well, first of all, this is your x-axis, okay? So this is like a mirror. This is how I think about it. So if you're going to get symmetry, okay, it's a bit like in national school, where not just national school, it's also on your course. If I get a rectangle and I have to draw in lines of symmetry, okay, so you generally draw one in the middle so that one side becomes a reflection of the other, okay. This would be another one, so there's another symmetry line there where the top is the exact same as the bottom. And if you remember, we cutted them out and we see did one side fit onto the other. Okay, well, this is the same, except this is our line of symmetry. So this is the same as the blue line I have here, okay? And I need to draw an image of that part down here that's going to be the exact same so that I get symmetry. Okay, so how do you do it? Well, the first thing with A is you look at how far is it away from the x-axis. And you can see there it's 2 boxes, okay? So therefore, I would go down 2 boxes down this side through the x-axis, okay? So I'm just going to delete out those construction marks so that they don't confuse you, but it's down here. And the reflection is called A dash, or the image is called A dash instead of A. So A dash is the image of A. Now, in the same way, I would take C, and it's 1, 2, 3, 4 boxes, 1, 2, 3, 4. So C is going to be down here. So C dash, okay? B is no distance from the X axis, so B dash is also going to be on that point. Okay, and then you get your ruler and you join the lines together, okay? So some people can see it straight away, others can't. I'm one that can't. So I don't even try, I just literally join the dots together. And I know when I join them together, I'm going to get that triangle that's a reflection of the one above it. Okay? And you can see it's just like a butterfly. So that is the points. I've labeled them A dash, B dash, C dash, and that's full marks for that one. Okay, now the next one. Which of the points A, B, or C is the intersection of the two triangles ABC and A dash, B dash, C dash? Okay, well, where do they intersect? They intersect here at B. Okay, so that was okay. Now F, the point PS lies inside the triangle ABC, where P and S is an element of OR, so they're real numbers. Use this fact to write down the coordinates of a point that must lie inside the triangle A dash, B dash, C dash, giving your answer in terms of P and S. Okay. P and S is a point that lies inside the triangle. I'm not rightly sure what they're asking here, but I'm going to pick this point here and I'm going to pretend that's my P and S. Okay, that does lie inside the triangle AP and ABC. Use this fact to write down the coordinates of a point that must lie inside the triangle A dash, B dash, C dash, given your answers in terms of P and S. Okay. Well, I'm thinking that if I pick the point 2, 3, 4, this point here, which is P dash S dash, won't that fit inside A dash, B dash, C dash? I wonder, is that what they're asking? That's my explanation of it. And then it says, write the coordinates of the point in terms of P and S. P dash S dash is how I would write that. Not 100% sure if that's what they're looking for in that particular one, but that's my take on it. So yeah, if anyone has anything different, do comment on the video. Let me know.